So thank you everyone for being online with us today. We're going to talk about our new line of product for renewable energy. As you are all aware, we need to generate more energy in a more cleaner way. Uh, the utilities are getting more and more saturated, so building power plants is costly and long. So having ways to generate clean energy to support the grid is something that is moving quick. It's a new trend. It's going to keep us accelerating in the next few years. So I think the topic is right on the spot, if I could say, time wise, during what we need to do in the next few years to be able to support this demand of more and more electricity. I'm trying to flip here, but it doesn't seem to work. Okay, here we are. So, quick agenda of the presentation today. We'll do a small overview of who's Delta Transformer. Of course, we're going to talk about transformer and renewable energy application. We're going to talk briefly about one of our differentiator, which is the epoxy vacuum impregnation of our product. We're going to also talk about efficiency regulation and also when it's the time to make the choice of transformer, what to look for and what's the trap to try to avoid, if I could say. And there's going to be a few questions at the end. So that being said, Delta has been around for 43 years now and counting. Delta has been founded back in 1983. It's a Quebec-based company. We currently employ over 200 people. So all of the design, manufacturing, shipping, testing is based out of our plant in Granby, Quebec. It's about 45 minutes east of Montreal. So we partner with local suppliers to try to have the best carbon footprint in our supply chain also as possible. We have a presence coast to coast, so we sell transformer only in Canada. We don't engage in the US market, but we cover the entire country with different type of products and solutions. We have a full team of sales at the sales office in Brossard, so we're 13 employees. You have a crew of inside sales, quotation, project managers. So if you need any type of assistance for budget pricing, feasibility study, technical question, our crew is there to support you. Our product are all ISO CSA certified. Sorry, some of our product are also UL certified and approved. We're an ISO certified company. We're a proud member of Electro Federation Canada, and we've been certified in the last year as a great place to work. So we do engage in lots of market segment, but the renewable segment is being very hot at the moment. So we do lots of solar installation, battery energy storage. We do lots with the utility also nowadays in regards with project. We're involved in pretty much any market segment where you'll find a transformer, dry type transformer. So any type of commercial construction to the oil and gas and hospital. So we do them all. At Delta, we only do dry type. We don't do liquid filled transformer. We do dry, but we do all of the types of dry type transformer you can find, from a commercial series, a general purpose, some specialty product for harsh environment, multiples, drive, power transformer, harmonic mitigating. So we have a complete offering of all types of transformer. And this is why we can offer some solution like the renewable energy with a very large offering of transformer depending on your application. So let's jump in the meat now with the transformer for renewable energy application. As you know, there's a big growth right now in the country for renewable energy. We estimate that this growth will just accelerate based on the fact that we need more energy. The grid are saturated. There's a higher demand year after year for electrical product, car charger application, all that stuff. So there's a big growth. So we need to find ways to generate more energy. So that's why we have all of these companies pushing for privately owned solar farm or wind farm. So we're going to see a big acceleration in the next year in that market segment. Um, so transformer, as you all know, it's an old technology. It's been around. Transformers have been around for more there than 100 years, but since probably the last 15-20 years, the technology of building transformer more efficient and specialty transformer has really increased based on all of these new technology, new type of loads, new application. So I would say my base of comparison is always a standard distribution transformer installed in an electrical room feeding a panel with multiple types of loads. So let's take that as a base of comparison. So renewable energy transformer are different beasts, supplying different type of loads, different type of environment, if I could say. A standard distribution transformer usually is going to have a pretty steady load, fluctuating from maybe 50 to 75%, depending of the time of the day and the building. If there's more demand for machines or computer, and at night it slows down a little bit, uh, versus a renewable energy transformer, where depending on your type of source, if it's solar or wind. But usually, if you have a solar farm, for instance, your inverter will output the maximum output at noon on a bright sunny day, and at night the output will be at zero. So you have these big fluctuation in loads over time compared to a standard transformer. Usually, we seek a loading factor of those renewable transformer at 100%. Why? Because since they're not fully loaded all the time, they have their peak depending on the time of the day for solar application. So we might seek a load at 100% during the peak compared to a standard transformer. Um, there can be some very long idle time. Solar farm, wood farm if you have no wind, solar if you have no sun. Your transformer will just be sitting there and burning, no load losses. So that's different than a standard transformer. Lots of thermal cycling, idling, small heat rejection from the transformer, full load, lots of heat rejection. So lots of thermal cycling, expansion, contraction of your coils and the core. Lots of stress on your dielectric insulation system, depending on the type of system, the type of inverter, those switching transients. Um, Transformer needs to be able to be built in such a way that sorry, the inverter can figure out if there's a phase loss, either on the grid or on the generating side. Um, Usually, we're going to see some very odd or special type of winding configuration. YY being one of the most common winding configuration we see in renewable energies. Um, what is also very different about renewable energy transformer, they are the center of a system. So they just don't take, feed from the grid from the primary and supply load on the secondary being one direction. They got to be able to be bi-directional, so they can take the energy from the inverter and push it in the building. Or if there's a battery storage system, they can be able to recharge the battery through from the energy from the building or the generating system. So that's also different. Installation location, most of the time those transformer will be installed outdoors. Depending on your location in the country, can be some very severe conditions. Customer expectation will be quite high. It's got to be I would say, a reliable system, expecting long life, and the cost versus your return on investment. So I have a question from Jason. So, what's the implication of a transformer being bidirectional? I'll explain that a little bit further down in the presentation. So again, we've talked about some element about the difference between a renewable energy transformer and a standard transformer. Again, when you're installed outdoors in the winter, you're exposed to lots of, cold and snow and blowing snow. And in the summer, you're exposed to lots of heat, if you have a rooftop installation, for instance. Uh, you might be subject to vandalism if your system is not installed in a protected area. Harmonics, as soon as you have an inverter, there's going to be harmonics involved in the system. Thermal expansion and cycling, we've talked about that. Your customer are looking for, proper lifetime, a very efficient transformer, good support to determine what is the best transformer for your system. There's many criteria we need to look at when we put a transformer in a renewable energy system. So all of that needs to be well taken care of. So again, when you take your transformer, when you select the transformer, you got to figure out, what's my load rating. So what's the output of that inverter that I have to supply? What's the rating I need on my transformer? Do I keep a little buffer? Do I go full load? Usually, we recommend, if you have a 300 kilowatt inverter, we recommend to use a 300 kVA transformer, again, because it's not fully loaded all the time. The ability to handle heat, again, you go from zero load, full load, exposure to outdoor temperature in the summer, can be very hot. So the transformer needs to be able to handle all of that heat. We need a transformer that is very efficient, because the transformer being at the heart of the system, the more losses you have in the transformer, the less energy you can provide to your building or your battery storage. You want something usually that's not going to be too noisy. You need something that is able to handle harmonics. We have solution that can either handle and or even cancel or treat harmonic. You have to have the capability of figuring out that phase loss interruption by how we build the core of the transformer. Connection type, depending on what system I have. Do I have a three-phase 4-wire grid on my building? Does my inverter has a three-phase 4-wire output? So this is all things that needs to be taken into consideration. Then you have the coil material. Do I go with copper, aluminum? The coil coating material, we use epoxy. We'll talk about that. The core type. Do I go with a standard three-legged core? Do I need a 4 or 5-legged core? Am I installed indoor, outdoor, rooftop, accessible to public? So those are all questions you need to ask yourself before deciding on what's the transformer you need to put in your system. As you all may be aware, the worst enemy of a transformer is heat. What will cause a transformer to eventually fail is heat, which will slowly, I would say, degrade the strength of your dielectric insulation system that builds your transformer. So our transformer are built with a 220 degrees Celsius insulation system. So again, the more the transformer will run warm, the more you run closer to that point, the shorter lifetime you'll get out of your transformer. So there's ways to have a transformer that's going to operate with lower temperature. One is the size of the transformer, the load of the transformer, the level of harmonics. So there's many things to be aware of this. If you overload a transformer, the transformer is just going to overheat and you just gonna really shorten the life of your transformer. So again, when we build transformers, by regulation, by CSA, if a 75 kVA 600 120 208 transformer, the output ampacity is 208 amps. So you should be able to run this transformer full load, drawing 208 amps all the time. The transformer is built for such. But if you run that transformer to that full load level all the time, 24 hours a day, don't expect to make 30, 25, 30 years out of your transformer, because you run your transformer so warm that you will end up destroying your dielectric insulation system. So our proposal for a renewable energy transformer, it's not a product, it's a solution. So you can customize your transformer depending on your system. So we offer different kinds of kVA from 15 to we even do large power transformer. Depending on your inverter type and the harmonics generated by your inverter, we can even provide transformer with a K rating, K13 all the way up to K20. All of the transformer meet the NRCan efficiency requirement when they fall within the regulation. Some products are excluded of the efficiency standards, such as auto transformer and any type of fully enclosed transformer like epoxy potted or NEMA 4 transformer. Those are excluded, so they will be less efficient. The core and winding performance. So usually we're going to see a 4 or 5-legged core that when we deal with YY connection. I have a few slides later on explaining this. Core design and winding type will have an impact on phase interruption. Again, this is really related to the inverter and the requirement of the inverter manufacturer. At Delta, we use epoxy impregnation of all of our transformer. I'll explain that a little bit later. And we can build transformer with higher efficiency than the minimum required by law. Again, I repeat that very often in my presentation. When you meet code, when you meet the requirement of CSA, you don't deserve a trophy. You meet the basic requirement. It's like, at school, you have 60% on your exam. You pass or you just pass. So the standard is the bare minimum. So you can do much better. So, and at Delta, we can provide options to bring the efficiency of a transformer to very, very, very high level of efficiency. There's a cost to that, but again, depending on your system, depending on how much money you want to invest, that can be a very interesting option. I've been talking about YY and 4-legged core. This is a picture that's been taken at our plant a few years ago. So that's a 5 kV class YY 4-legged core. So as you can see, you have your typical, 3-phase, phase A, B, and C mounted on the 3 legs of the core. But on a 4-legged core, what we do is at the end we bring a 4th leg, and in the case of a 5-legged core, we have the same leg at the other end. So it's a core leg, fully laminated, but there's no winding dropped on that leg. Why do we have to do those types of core? Mainly, we're going to build a transformer based on the requirement of the inverter. So if you have a building with 3-phase 4 wires, so that the transformer needs to have 3-phase and the neutral, so a Y connected transformer. And if your inverter is as a 3-phase 4 wire system, again we need a Y connected winding. So we end up with a YY transformer. And there's many ways to build YY transformer. We can build a YY transformer on a standard 3-legged core like this. We can also do 4 or 5-legged core. Again, we don't decide. Usually it's the inverter manufacturer that will recommend, or will require a specific type of core. And why is so? Mainly, it's in the case of when you lose a phase on your grid or your inverter side. And let me explain. On the typical, I would say, three-legged core transformer that we have like here, so you have one winding per leg. So if your primary is connected, let's say in delta or Y, whatever, so you energize here. So if you lose that phase here, but you still have this phase and this phase energized. So if we represent that here on that core, we lose this phase here, but we still have this phase and this phase energized. So the phenomenon in the transformer, when you energize your primary, you create a magnetic field, and you have magnetic flux circulating in your core in a clockwise and a counterclockwise rotation. So what happens if you lose this phase, but this phase here is still energized? You still have magnetic flux circulating through your leg here, where you lost a phase. But since you have magnetic flux going through, there's still going to be some voltage on the secondary side of that coil, and the voltage drop might not be enough for the inverter or the system to understand that, oh, I've lost a phase, I need to shut down. So the solution to this is to create a core with a four or a five-legged core to provide another path for those flux to go. So when you lose a phase, instead of just going in those two legs, your flux will have a fourth or a fifth path to go. The result will be the magnetic field in that leg will be a little bit less. So the voltage, the residual voltage that you'll see on your secondary winding when you lose this phase will be low enough for the inverter to understand that, or the system to understand that I've lost a phase, I need to shut down. So that's the requirement, which is most of the time demand or required by the inverter. We don't see lots of system with standard three-legged core. We do see it, but most of the time it's going to be a four or five-legged core. So of course, adding those four fifth leg will increase the size of the core. More material is going to need a larger enclosure. So there's a cost associated to that. And again, when you select your transformer, if you say, never mind, I'll still use a three-legged core standard transformer. If you lose a phase, you might end up with, frying your inverter and causing lots of damage to your system. So sometimes trying to save on your transformer can cause lots of costly dollars down the road. I'll talk a little bit later about the bidirectional thing. Is there a significant difference between a four or five-legged core? Yeah, the difference will be mainly in your in the size of the core itself, and it's going to be the price. So mainly a five-legged core. Let's say you start with a three-legged core. If you a four-legged core, you have 25% more material, and a five-legged core, you have 66% more material. So it's a big impact on the cost. Again, it depends if you go with copper or aluminum windings, but you can figure out, rule of thumb, four-legged core versus three-legged core, you may talk, 20% more. If you talk five-legged core versus three-legged core, you may talk 40, 45% more money, more or less. Yes, five-legged core could protect better than a four-legged core, but again, it depends what's the inverter requires. Some inverter can work fine with a four-legged core, and some it's going to be mandatory five-legged core. So usually make sure that, depending on what inverter you're going to put in your system, to select the right core. 80% of the time, a four-legged core could do the job, but in some cases, we've seen requirement where it's five-legged core. Yes, usually it's gonna be indicated in the inverter spec sheet requirement transformer for five-legged core. I don't have any example with me, but it's going to be showed on the inverter spec sheet. Sorry, I need a sip of water. EDI. So at Delta, we do vacuum impregnation of our transformers in a vacuum chamber, and we use epoxy. We don't use just plain varnish. We don't use polyester resin. We use epoxy. Why? Because epoxy is the best coating material you can use to protect your transformer. And we don't do the vacuum process just on the windings. We do the vacuum process on the entire core and coil. So the picture that you see there, that's in our power section, that transformer is probably a 5 MVA, 25 kV class. So we take the entire core and coil, put that in the chamber, we close the lid, and while we vacuum the chamber, we inject epoxy, we fill the tank with epoxy, so the epoxy will go everywhere, all the windings, all the layers. We even seal the core and the core structure with epoxy. And one of the best characteristic of epoxy is that once it's cured, the epoxy coating will remain flexible. So a varnish is stiff as a piece of glass, same as polyester resin. So by being flexible, when your transformer is sitting at idle, no load, it's probably going to go up to 100 degrees. But then you apply, full load, or your inverter is pushing the maximum output at noon. So you go full load, the temperature of the transformer will go up, your winding will expand, your core will expand a little bit, and then at night it's going to cool down, it's going to contract. So the epoxy will have the capability of expanding and contracting with the fluctuation of load much better than a transformer coated with varnish or polyester resin. So that's why you won't see after a few years flakes or cracks in our coating, because it's flexible. It's also a better dielectric than varnish and polyester, and it's a very good moisture repellent. Um, Varnish and polyester resin will act more like a sponge. It will attract and retain humidity. Epoxy will repel. And I always do when we do tour plant. I go on the shop floor, I take a piece of epoxy or a coil and have this bottle of spray water, and you spray water on the windings, and it's like wax paper, the water is just repelled. So that's why we use epoxy at Delta for all of our products, because it's the best coating material, flexible, better dielectric, better epoxy, better humidity repulsive material. So when you open the panel, this is a typical, I would say, VI transformer, low voltage transformer we build at Delta. Sometimes some of our low cost competitor, what they do, we call it the paper and varnish technique. So mainly they will build the winding, the coils themselves, and before putting the coils on the transformer leg, they will just either spray the windings with varnish or just manually take the winding, the coil, and dip it in a drum of varnish. So you're gonna have varnish on the outside of your coils, but within the coil, when you look at the winding from top, it's all layers. You have no protection material. You have no varnish. So when you expose those type of transformers to humidity, harsh environment, they will fail quite rapidly compared to a transformer that's been protected by epoxy. When we were talking about a transformer that needs to be bi-directional, I think this nice sketch that Alia did really explain why. This is a typical, I would say, building or development where you can have multiple type of wind farm, solar panel. You have your grid and your medium voltage transformer. So if we take, for instance, here the wind farm, so you have your wind farm, bringing that to an inverter, you have a battery storage system, and then you have your transformer that goes through that building. So the transformer needs to be able to take energy either from the wind farm and the inverter all the way to the building, or sometime if those battery storage needs to be recharged, it's can be the energy of the wind farm, or it could also be the energy from the building. So the transformer needs to be able to either get the power from the inverter and feed the building, or get the energy from the building and feed the inverter to recharge the batteries. So that's why when we build renewable energy transformer, we don't label the winding primary and secondary. We label the winding grid side and inverter side. So you know that you need to connect the grid side to your building and the inverter side to your inverter. Again, depending on your voltage. Your building might operate at, 600 Y347, 208, 120. Your inverter might be at 480 volt Y277, could be at 208, could be at 600. So you may end up with a transformer that can have the same voltages on both sides, but you need to know which side connects where. Why it is important when you deal with bidirectional transformer. First of all, it's the what we call the inrush. When you energize a transformer, so when the transformer is sitting unenergized and you energize it, there's a phenomenon called the inrush to create this magnetic field in the core so that the primary and the secondary winding can work, if I could say. On the first 10 cycle, you're going to have this massive demand of energy to magnetize the core. Core is like a sponge. It's going to need lots of energy to get magnetized. So that peak of inrush sometimes can be 10, 15 times the nominal current. So it's a very short peak, 10 cycles. So it's probably 1/10 of a second, but still. So depending on which side is going to be energized, if you energize by your secondary side, you energize by the coil that is the closest to the core. So you're going to increase this inrush probably by 2 or 3 times. So you may end up with 25, 30 times your nominal voltage. So that's one thing. The other thing that is important is your full capacity adjustment taps. On which side do you want them? Usually we put those taps from the primary source. So on a typical system, is the primary source more your wind farm or your building? Is that just a system that will just generate a little bit, or is it just a system that's going to generate a lot? So if your main source of power will be your wind farm or your solar farm, then the taps should be on the proper side, if I could say. And if you use the building a lot to charge back your battery in cases where the transformer is going to be used for a battery energy storage system, but you want to make sure that you're going to have your tap on the other side, because you want to make sure that if you're building at 600, if it's at 580, but you supply the right output voltage to your inverter, because if you don't provide the right voltage to your inverter performance will drop. You can have malfunction of your inverter. So that bidirectional duty, if I could say, is quite important in those transformer, because the typical transformer installed in an electrical room feeding a panel will be fed by the grid 600 and will feed a panel. So it's upstream, downstream. In the cases of renewable energy, it's the energy will flow from either building, inverter, or battery. So the transformer is like an energy router, if I could say, in those cases. So transformer will be sitting at the center of your system: inverter, battery, solar panel, wind panel, wind farm. You have your grid, you have your panel, you have your building. So again, this is why it's very important when we select the transformer to know what's the system, what's the entire system is made of what, and to make sure we provide with the best transform with the best solution. So the features and benefits of our low voltage transformer for renewable application is, bidirectional flow. They meet all of the Canadian standard for energy efficiency. They carry a 10-year warranty. And again, we can pretty much customize them the way you want. So it's not a standard off the shelf product. It's a custom built product for each application. Um, when we deal with outdoor, more and more outdoor, as you know, and 3R, as per CSA, is approved for outdoor application because it's rated weatherproof. That being said, the weatherproof in California or Southern Ontario and weatherproof in up north Manitoba is different. So at Delta, we have an option called 3R Enhanced, for which what we do is on the typical 3R enclosure, the air to cool the transformer will be sucked in by the bottom here and will be exhausted at the top. So what we do in those cases to bring the transformer to an enhanced feature, so we put those aluminum mesh filter at the bottom where the cold air goes in, and at the top we put those filter again. So those filter will prevent the ingress of snow, rodent, debris. So it's a more rugged option for, I would say, our Canadian type of environment when you deal with outdoor type of installations. Uh, we also do some large transformer, medium voltage, directly connected to a large solar panel farm, massive inverter, and we can connect those transformer already back to the utility all the way up to 35 kV, 150 kV BIL. So same principle as a small low voltage transformer, but with for those massive. We did a few large projects like that over the last few years. So again, it's all custom built depending on your requirements. When we deal with medium voltage, construction is the same. We have those filters. Well, we can also add some anti-condensation film inside because there's massive heat rejection on those transformers. So you want to make sure that when you are at, minus 40 outdoor and it's, plus 180 degrees C inside the transformer enclosure, you have no condensation and no water dripping on your live part. And we also install space heaters with thermostats. So in cases where you have to do a shutdown, we keep the inside of the enclosure, I would say, warm to avoid moisture buildup. Our epoxy, you can start the transformer cold start up to minus 50, but if there's frost on the winding, the frost might cause striking. So those space heater will prevent that. Our current strategy for the market is what just like we do today. So we conduct webinar to make all of the industry player, engineers, and producer aware that what was the role of the transformer within your system, and then we work with the developer and the system to make sure that we craft the transformer especially for each application, KVA, voltage, connection, core type, K rating, and all that good stuff. And then we support by executing, by delivering, and ensuring that the transformer at site is installed, is commissioned, and functions and operates properly. A little bit about efficiency regulation because that's kind of the base of any transformer, and I would say the purpose of generating green energy is to be efficient. In Canada, we have NRCan, that's the federal government. So the law, it's a federal law that transformers shall have a minimal efficiency. And we use CSA CO2-18, which is the current edition, to determine which are the efficiency requirement for each transformer. So depending on your KVA and your voltage class, so that's 1.2 kV all the way up to 200 kV. So as you can see, the more you go up in size, the more you go up in voltage class, the more you got to be efficient. But the trick is, for low voltage class, 1.2 kV and less, we have to meet this efficiency level at 35% load, and any voltage class above 1.2 kV, we need to meet this efficiency requirement at 50% load. So that efficiency curve from different manufacturer can be quite different depending on your transformer construction. So just by saying, yeah, I'm efficient as per CSA, yeah, it means that at that point, at 35% load, you meet this point, but at 75% load, what's your efficiency, Mr. Manufacturer? There can be lots of difference between manufacturers in that regards. Losses in a transformer, there's two type of losses: no load losses and load losses. So the no load losses, it's the core. It's strictly your core and your excitation current circulating in your primary winding to keep that core magnetized. And you're stuck with them. You energize a transformer. There's nothing connected to the secondary or grid side or inverter side. There's going to be some losses in the transformer, and you're stuck with them. And then the load losses are the losses in the winding. So the more you apply load on your transformer, the more ampacity current will run through your windings, the more heat rejection you'll have on your coil winding wire, so the more losses. So ways to make transformer more efficient is lower those no load losses in the core and increase the size of the wire for your coil. So if you have the same ampacity, but going through a wire that is twice as big, the wire will heat less losses, more efficient. So that's one of the way. This is why it's more costly to build a more efficient transformer. And please remember that the load losses, the losses in the winding, they're not linear, they're exponential. So the more you load, the less you are efficient. So at 50%, you generate 25% of your loss because they increase to the square of the load. So 50% load. So 0.5 times 0.5 equals 0.25. So you take the transformer data sheet. If the full load is 1,000 watt at 50%, I'm going to generate 250 watts of loss. But the more you load, the more those losses will increase. So again, it's important to understand this when you select a transformer. Sorry. So when you select a transformer for any type of application, make sure that you analyze your needs, the requirement, and then what winding material will I go with? Copper, aluminum, what temperaturized transformer do I need? What's the impedance I need? Do I need a specific coating material such as epoxy or something else? Does it got to be vacuum pressure impregnated? Most of the time, we strongly recommend to have at least a VPI transformer, and preferably with epoxy. Look at the efficiency, not just the fact that it's NRCan approved. What's the losses of the transformer, so you can figure out what's the efficiency of the transformer under full load condition. Do I need a transformer that is less noisy than a standard one? Do I need a K factor? Do I need a static shield? Do I need to oversize my neutral conductor? Because when you have harmonics, those harmonics current, they come back by the neutral. So those are all questions you need to ask yourself. And as a customer, as a consultant, how can I understand those differences? If you have two drawings or two proposals from two different manufacturers, well, look at the drawing or the spec sheet and look at all the basic parameters like the material, the temperaturized, the impedance. Compare your impedances to ensure that your full capacity on your breaker are compatible. You may have a better cost-efficient transformer, but you may have to change your breaker for a higher K, so you won't save much in those cases. Make sure the winding diagram for the proper coupling, is it delta, is it Y, do I need a neutral? Again, look at your efficiency and losses. And you can conduct a loss evaluation. If you're buying a big lot of transformer or a large transformer, just don't look at your acquisition cost. Look at my transformer cost me 10 grand. That's the losses of the transformer. That's my cost of kilowatt. That transformer is going to be installed for 20 years. What's my cost of energy over 20 years? So maybe manufacturer A at 10 grand will be more than manufacturer B at $8,000 for that same transformer. But maybe you're gonna save $20,000 in losses over the lifetime of the transformer. So make sure you take that into the equation when you select your transformer. And please watch out for all those misleading data on drawings and quote when it says efficiency as per CSA, standard impedance, meets Energy Star. Confusing wiring diagram, don't use T connected transformers on renewable. K factor of 1. A K factor is the ratio of losses under no harmonic and harmonic conditions. So a ratio of 1, that means there's no K rating. You have a standard transformer. If you have no indication of losses in watts on your drawing, NRCan, the website, they have all the listed manufacturer who reported their values. They're all there. And if you miss information, confirm with the manufacturer. You're the customer. That's the question to make sure you have the right product, the right transformer for your application, for your system. Thank you. I'll take a sip.
All right, excellent. Thank you so much, Mario, for that insightful
Mhm.
presentation. So now we have some time for questions from John and Ronak, who have
Yeah.
prepared some questions for you.
Mhm.
So if we can ask them to join the virtual stage. Ronak, unmute yourself, and John, same with you. I'm gonna pin you guys here. Spotlight. Okay, and you are all on. All right. So, John, do you have a question for Mario? I
I
believe so.
do. I
Okay.
do. First of all, Mario, thank you very much for your presentation. A lot of great information in there.
Welcome.
Obviously, today's requirements of energy, renewable applications is substantial. So it's great to see that Delta is at the pinnacle of
Yeah.
designing transformers for these
Yeah.
applications.
Yeah.
You did mention something briefly in your presentation in regards to solar applications and the powering of inverters.
Yeah.
Uh, I know you talked a lot about power, about four leg and five leg, but
Yeah.
how do these transformers actually handle the high frequency switching harmonics produced by these inverters?
The Again, depending on your transformer type and construction, so as you do rectification from AC to DC, like an inverter, there's going to be harmonics that will be generated. And from a transformer, I would say, point of view, if I could say, when you have a transformer exposed to harmonics, the load that the transformer physically sees or applied to the transformer is going to be higher than the load you think. So let's say you apply 200 amps of load on a 75 kVA transformer. You think you have 8 amps of loose, if I could say, but let's say you have high harmonics. So the harmonics will create extra load on the transformer because all of those harmonics current will add to your fundamental. So the actual load that the transformer will see can be 225 amps. So the good thing to do in those cases is if you don't run a transformer under full load condition, you're going to have that room to handle those harmonics. But in the cases where you deal with renewable and you size a transformer for full output at the same output as the inverter, you need that room. So you need to apply a K factor to a transformer. So by providing a K rating to a transformer, what we do, let's say you talk about K13, the transformer will just physically be larger core, larger winding. So when the transformer under harmonic content, instead of seeing this 200 amps, which going to represent maybe 230 amps, so the fact that the transformer is bigger, he's going to be able to handle those harmonics. He won't overheat. He won't be noisy. So K rating is the right answer.
Thank you.
Uh, Mario, I have a question for you regarding the transformer specifications.
Yeah.
You had a slide regarding what how is it that the engineer and consultant should specify a transformer? So, in your experience, what are the most common transformer specification mistakes in solar or battery energy storage system?
The mistake we see the most is the core construction, because they're gonna specify, let's say, a YY, but they won't specify a 4 or 5 legged core. So again, everybody wants to win the job, so everybody wants to provide the quote with the most cost-effective pricing. So if you don't specify the proper core, of course, a 3-legged standard transformer YY will be more cost effective than a 5-legged core. So that's, I would say that and the K factor are the most, I would say, common omissions that we see on specs.
Okay, Mario, again, you did touch on this as far as the no load losses that are prevalent in the renewable
Yeah,
applications.
yeah.
Just wondering, what are some of the design features of the Delta transformers that you actually have in the actual design itself can help with these losses? And do you have any
So,
installation suggestions
yeah,
to help with these losses as well?
yeah, well, I've explained that, the no load losses are the losses in the core. So one way to have a better efficient transformer is to lower these losses. So despite the fact that we all have to meet this minimal efficiency requirement from CSA, when we get the core steel at the plant from our vendor, they come with a mill test. So let's say core steel, depending on the grade, will be better or not as good. So the better quality core material is easier to magnetize. So let's say we receive a batch of M4, which is one of the very good type of core steel. So we're gonna select the rolls with the best. So we're gonna take the cream of the crop, if I could say. So we're gonna take the core steel with the best mill performance in regards to efficiency, and we're gonna keep those for those type of renewable transformer, EV car charger application, where by using, I would say, the standard M4 from that batch with, I would say, not as good performance, we're still gonna meet NRCan that minimal efficiency requirement. But by using the best core steel that we have in that batch, the losses in the core will be less, and we're gonna have a better product. It
Maria, I
makes
have
sense? Yeah.
Maria, I have a question regarding the ambient noise. So, is there a significant difference between the special design transformer versus the standard units?
The noise level that we have to meet for those is the same as a standard transformer, so from the same CSA requirement. But again, depending on your installation location, we can build transformer with lower noise level than a standard unit. Mainly what we do is we play with the induction level of the core. We lower the induction, not as noisy, if I could say, but by lowering the induction, your magnetic field is not as strong, so you lose efficiency. So it's a balance. It's a good balance between everything.
Thank you.
Yeah. Do we have time to take
Um,
some questions from
we have
online?
1 minute remaining, so
Okay, I'll try.
there is a quick question if you want to see. There's one from Mike.
Yeah, I got one from Jason here and Mike. Let me go. With a transformer intended to have bidirectional power flow, when you energize from what we traditionally call the secondary side, you mentioned that the inrush could be higher since the winding is closer to the coil. Would you recommend increasing the rating of your overcurrent device to handle that? Usually, that's the right thing to do when you know that you deal with a higher inrush. Uh, Either increasing the rating, or most of the time, it's if you're protected with fuses, it's to change the time delay curve of this fuse, or the most, I would say, popular or right thing to do is to go with a field adjustable breaker that you can adjust your tripping point like this. So usually that's the way you're going to be able to mitigate those inrush effect. Got one here from Mike. Have you heard much on the impact of sub-synchronous oscillator in the power system, and if there's anything that can be specific on the transformer construction to better withstand that? Yes, that's what we call when you have multiple system switching on a system working in parallel. Uh, on your waveform, you're gonna have ripple like this. So at the peak of that ripple, so if your peak is at 600 volt, but the peak may be 675. So there's ways to mitigate that in the construction of the transformer. Again, it's going to be with better dielectric insulation, higher kVBIL usually, because the higher the BIL level of your winding is, the more sturdy your winding will be to sustain any type of external peak and surge. And this is again a good way to make sure that on top of your sine wave, when you have those peaks traveling on your sine wave, having a higher BIL usually is one of the way. There's electronic features also, but from a transformer, I would say, point of view, higher BIL is one of the best solution. You have a more sturdy, robust type of winding. When we do those large farms with medium voltage, usually the primary will be at 150 kVBIL and the secondary can be at 45 kVBIL instead of standard 10 kVBIL, just for those type of phenomenon you've been talking.
Okay, great. So I think that ends our program. I think
We've been
it's
asked
1:02.
if we could share the PowerPoint. I
Yes.
guess we could. Yes.
So
So yeah.
exactly. So by tomorrow morning, you will have in your inbox a link to the recording of this presentation and as well with the PDF presentation for you to review. And there will be a short survey going out later this afternoon. So we would really appreciate your feedback on today's session. And we will also announce a winner of the $100 gift card later this afternoon via email, as we're just going to generate the list. So thank you for everyone who made it out to attend today's session. We really appreciate your participation. Thank you to our speaker, Mario, and to our contributors, John and Ronak, and to my co-host, Aaliyah. So thank you very much for being here, and we look forward to connecting with you in the future. Bye-bye.